in the assignment folder. A lot of lecturers don't set up Moodle this way. They have a front page that goes assignments and topics, which is fine, but at least with me, everything runs in order of the weeks that we do it. So if you're looking for something, you just got to go, oh, I think I've covered that about week 4 or 5 to find out where drop boxes are and stuff like that. So in this case, I would seriously download those student examples. I said they weren't A students' works, they were more like C's, but we went over a lot of things this morning which will help bump that mark up. And it just gives you a bit of idea, especially with these labs where you've got 2 screens, you put the PDF on one, you bring your drawing to the extents on the other, and you get a pretty good idea if you're starting to get into the right ballpark with what you're doing. Let's go to the assignment. By the way, anything with a revised date on it, as I said before, I'll try to give an announcement first, and then that date will change. All right. The announcement normally tells you what the story is. So I mean, I might change a small typo. I won't change it for that. You know, where I've spelled the T-E-H or something. But if it's something that's very important, then I will announce that to you. So over the years, that sort of thing's happened. There's been a wrong spot height or something like that, which throws everything out. And so it's important to have your emails coming through. So yeah, I'm just going to save everything if it's not already onto. And save the logo as well. Now you don't want to be just going okay to open these things. What I may or may not have told you last semester is it's not a good idea to just come into this lab with your memory stick and double click on the file, you know, like you would a Word document or an Excel file. There are different versions of AutoCAD in this lab, and there's one called Civil 3D, which is also doubles as a survey and a design package for engineers. If you accidentally double click on it in Civil 3D, things are not as you would know as you used to. You will find that sometimes the coordinates go up the WOP, and sometimes other things don't work quite as well. Also, you'll get different commands along the front, and the AutoCAD ARG file may not work. But if you open AutoCAD the way that I explained it and Ingrid explained it, we're going down the bottom, AutoCAD English, and then English there down the bottom corner. I'm not sure whether you guys can see that very well, but if you go that way of doing it in the labs here, you won't have any issues whatsoever. Fire AutoCAD up, now double click on the file and it'll open up in the proper program. At home on your laptops, no worries, double click, bang, you've only got one version of AutoCAD there, that should open it straight away. So don't concern yourself about whatever happens at home. Right. So I'm predicting, for those that have got the clock watch on me tonight, I'm predicting that we probably should get through this first section of the last section of notes in 10, 15, 20 minutes, somewhere in that vicinity. And then we will look at the survey drawing that's been provided there. And then we'll start putting the title block in and that sort of thing, okay? So possibly the lights might go out a little bit, which is a shame. It's better if you've got a bit of daylight going in as well. And we'll go through that and we'll show you how to do, at least put the title block in and the logo. If we've got time, I might show you a couple of other things in terms of changing some of the text types. I've also got to go over some calculations that you need to know as well. So I haven't put sheet numbers beside each of these, but what tends to happen is I'll only give you the first section on week 1. So we'll stop at the bottom of this notes will be week 1, and then I'll print next week when I upload it will be a PDF which will include week 2 notes and so on. Okay. And normally I put pages 2 to 3, 3 to 7, etc. I haven't done that. There's a very good reason for that, which I won't go into. I'm currently taking some stuff out of this course and I'm making sure it's in the survey course, which is more the roading side of things, or the second part of the survey course. So I'm up to about week 5 or 6. So at the moment I'm not putting specific numbers there. Okay, so we're talking about AutoCAD standards, and more specifically what most of you want to know is what the hell am I supposed to do in the assignment as far as standards and things go. The first page here I've pretty much covered this morning, to do with everything to do with penalties and drop boxes and late hand-ins and backing up and that sort of thing. And there are real jobs out there at the moment in just AutoCAD itself, but generally you'll see a lot of companies, even surveying work, they'll be advertising for experience in 2D and 3D. And generally speaking, they're talking about a program like AutoCAD for the 2D, and they're talking about a modelling program like 12D, Civil 3D, or Revit for the other part. They don't expect our guys to leave Unitech and be the world's greatest engineers, but because we're doing technical stuff here, they do expect you to be able to be work ready. So they should be able to give you a CAD file to open up, print, do a few alterations to the basic stuff as you're starting to learn in the company. So they employ our guys and girls because you're ready to start being productive for them. If you're employed as a surveyor, they would expect you to know how to do levelling. They're not going to go, well, okay, come over here, I'll teach you how to use a staff and a level, right? So they expect a certain level and definitely certain amount of functions on AutoCAD is what they're expecting as well. How do I know? Because most people in charge of the offices now, after 17 years of teaching here, are my ex-students. And they've been through the same pain that you guys are going through, and they know that if you've got an A in my subject, you are someone that they want to hire. Okay? Equally, they know if you've squeaked through on a C-, they possibly will put your CV to another side if it's a drawing job. Now, I'm not saying everyone has to be good at drawing. Goodness me, I hated doing Geotech. You'll find that out as I start talking through the semester. It wasn't my best subject. And the first thing I did when I got a job, I worked for the Ministry of Works, and the big boss went, oh, let's give everybody a bit of experience of everything. And I'm like, uh-oh. So I was in central Otago, and within 5 minutes I was on a bloody staff in the mountains in the snow. And guess who was the one walking around getting freezing cold, and who was in the four-wheel drive with the heaters on? It wasn't me. I was the one walking around. Then they put me in a soil lab. Yep, one of those things like there, next door, which half the engineers are going to have to go to. And every day I was breathing dust for 3 months. Absolutely hated it, okay? But the point is that, you don't know where you're going to end up, and okay, I knew I wanted to be a draftsman at that point, okay, which was inside by the heaters and making sure I was doing design work rather than outside. The surveyors were the opposite. They used to come into the office every day, and you could feel them getting itchy if they couldn't get outside by 8:30 in the morning, all right? And they used to grab them, lasso them and tie them to the drafting desk for 3 months. That was so much fun. So you don't have to be good at everything, but you can't avoid drawings. I'm sorry. If you're going to do engineering, you're going to see drawings in some capacity, and you probably aren't going to be able to avoid using a laptop, and you're probably not going to be able to avoid opening up AutoCAD drawings in some capacity. If you do go on to do the advanced course, the surveys won't need to do 12D because they will be doing it possibly this year, possibly next year. I'm not sure how that all works out, but there are some 12D courses that you guys are going to have to do, so you won't have to worry about. We used to let the surveyors do the modelling course, but we don't need to do that now. But certainly, Sosifo, you've done the modelling course, yeah? Pretty good?
Yeah, it's good.
Yep. Yep. So you get to model 3D structures as well?
Yeah, 2D and 3D.
2D and 3D, yeah. So, generally speaking, industry now know that our degree students do that. They are tending to pick our degree students before they take someone from Auckland University, because they may be very good at the theory, but they've got to train them up for 5 or 10 weeks and they haven't got any productivity out of them. So that's a huge advantage. Okay, now what I do here when I go through my notes week by week is, and it's only verbal, there's nothing highlighted, is I'll say something like, that question there is in the test. Alright, you know how I said I had 120 questions in my test? That is one of them. I've just given you one of the questions. If you're lucky enough to get it, you should be able to remember that. However, I will now go on to explain how we get those answers on the right hand side, and you should be able to do it with any numbers whatsoever. You may not get that question in the test because there's 120. It's going to give you 10 multi-choice and 10 calculating ones, okay? So that's how I run the course. You'll find me, I'll pause from time to time and say, by my memory, there is a multi-choice question on that in the test, okay? What I would do personally is I would probably go back, open up these PDFs and highlight the bits where I've talked about. At least it gives you half a chance of getting the answer right. With my multi-choices, normally there's 2 answers that are stupid and 2 that are really close. And if you know what you're talking about, you should be able to get the right answer. Okay? So why have we started with imperial to metric?
Because the old surveys were imperial and we currently use.
It's the correct answer too. And it's a real shame I'm not giving away a half mark for that. I should have got a half mark for that. Were you the one that got the half mark this morning?
Yeah.
You were. I give away lots of half marks, but there is a rule: no more than half a mark for any assignment. But the good thing is, no one else got it, so thanks. Yeah, he's dead right. He's sort of right. Your first job when you in the workforce is probably to make the boss a cup of coffee. The second job is to water the pot plant, and the third job is to go to the council and get as many survey drawings as you can from council to make sure there's no problems, i.e. there could be iwi issues there, it could be geological, geotechnical, it could be environmental, whatever. You go to the council, there's usually another Unitec student standing at the front that can't quite get a decent job, so there's, oh, no, I didn't say that. So he's gone up the back to get all the plans for you, and he delivers them to you, and you open them up, and the first thing you see is on the scale, you see 1/8 of an inch to a foot, and you're like, what the hell? And you look at your own scale rule, you've got 1 to 50, 1 to 100, 1 to 200, 1 to 250, And the boss has told you that as soon as you get back, you've got to draw that up. And you've got to draw it as close as you can to scale because we're going out on site and we want to start pegging stuff off from corners, boundaries, whatever, right? Not as hard as you think. Luckily, for me, my foot is, well, actually it's a bit exaggerated. I've got pointed shoes on tonight. But my foot is exactly a foot. So I know what a foot is. It's about that much, okay? Give or take whether I trim the toenails. But for you guys, there are 12 inches in a foot. Right, so if you can remember 12 inches in a foot, you can do all those calculations down the side because it's very easy. The two numbers you're doing is 8 and 12. 8 times 12 equals 96. So the nearest metric is 1 to 100. And you'll find that when it's that close and you get your scale rule out, pretty much your dimensions will be spot on. Okay? Handy to know, important to know, and yes, a couple of 3 of them are in the test. Anybody know what a chain is? Well, actually, everyone's kind of getting that right. Someone said a cricket pitch. Which is that? Oh, that's right. Yeah. Yeah. No, it's dead right. When the English came out here, they had that chain measurement and they would put a lamppost exactly a chain apart, which worked fantastic in England for 1,000 years. They came to New Zealand and did it with all our earthquakes and everything else going on, and the distances became quite large and the lampposts ended up like this. But yeah, a chain is 22 yards, which for the Indian students that don't come from Fiji is a cricket pitch. Okay, so a chain is a measurement. It's good to know that. Because if you see on there 5 chains, 5 cricket pitches, you kind of got a bit of an idea of what your distance. You're not talking 400 kilometres, you're not talking 400 millimetres, right? And by the same token, when I explain metre drawings to everybody in class, you would expect if you're doing a site to always be talking in metres. You don't tell someone that there is a tree 125,422 millimetres away. You say the tree is about 112 metres away, right? So it's exactly the same with these things, getting a wee bit of an idea of your distances. Having said that, the weirdest thing about sites and survey drawings is every now and then they'll throw in a millimetre. Like, oh, it's a manhole. It's 1,050 millimetres. Or the lid's a 600 millimetre lid on the manhole, you know. So for some reason, if it gets under a metre, everybody starts talking millimetres, which is sort of throws you a little bit. The next thing I've done here is I've given some common site scales. So generally with site drawings, they're big numbers, and you've got to use that XP factor to set your scales, generally speaking. And when we do our long sections, we're going to do something called a distorted scale. I touched on that this morning. And there's some of your, the vertical scale is the one that's distorted. There, and so therefore, remember the bigger the smaller the number, the bigger the scale. So if the number starts going 1 to 50, 1 to 20, 1 to 10, you're making the vertical very large. Okay? Thing you have to keep in mind. I have a question on this too, and I guess the most important thing for students to know is that in area size, it doubles every second size of paper. So an A4 to an A2, you're talking, sorry, it's 4 times the area size, I beg your pardon. So from an A4 to an A2 is 4 times the area size, but the scale is 2 times the difference. From an A3 to an A1 is 4 size, the scale is only 2 times the difference. And so that's something to get your head around a little bit, because it's really important in a drawing to put whether it's an A1, A3, A2 on the bottom of the drawing. No use leaving that out. No, I'm only saying it now. If you just put scale 1 to 100, and the client hasn't got AutoCAD, asks for a copy, you print it out to him, you might just give it to him on an A3 sheet, and he's putting the wrong scale rule on it because there's no reference to whether it's A1 or A3 or A2 or A4 or whatever. Very important to put that on. Don't leave it off. Okay. Every office has a little Hitler in it, and that little Hitler's usually got lots of pimples, and there's a teenager about 17 years of age, and they know everything to do with AutoCAD and the internet and everything else to do with computers, and everyone, including the CEO, bows down to them. So when it comes to CAD, and I've been one of these people, by the way, I wasn't 17, and they make up the office symbols. Now, you'll find that when you join an office, you'll get a lot of symbols, not just 1 or 2 or 20 or whatever's there. There'll be hundreds, but there'll be company standards, there'll be New Zealand standards that you have to follow. I'm making things very simple. I'm about to go through the symbols that you need to use for the job that we're working on. You won't need the railway, you will need the bush. There is some bush there off the top of my head. I want the bush symbol to be like that. You need to use the cloud command in AutoCAD. The same one you did for drawing trees and things with Ingrid and myself. A house. You do not have a house on Unitec, but you do have a building. When it says house there, that means anything with concrete on it, and that is a structure. So you have got a building called the Concentrix building or the IBM building. Please use that hatch, close as you can to that, for that building. We don't have a hedge, we don't have a trig station, we do have a gate. I think it's not too far from gate 3. If the gate comes into play, I don't know if it's there or not, use a symbol like the bow tie. Not sure if there's a fence, I'm not sure if there's a boundary. If you find one, I want it a line type like that. Please ignore the cut and the fill batter. We will go over some of that next week when we do design contours. There is a swamp. Actually, it's more like a wetlands, and because it's winter, it's more prevalent than it is at the beginning of the year. So this is what I want you to do. I want you to hatch using the dash hatch, and then I want you to do a hatch on top of that using the one, I'm not sure whether it's grass or swamp, you will find it in there, and I'd like it every second one. So you need to set the scale so it's right. Now let's just say that the wetlands or the river or whatever, the creek, is open at each end. You might be able to draw a line from there to there and then hatch it, but the chances are you're probably going to have to go around it drawing a P line. The reason is that this file came from a 3D file originally, and I flattened it, and it might look in plan view like they're touching, but they might well be quite a bit apart. And because of that, it's the old Al Capone theory going on, the hatching will escape given a small hole, okay? So I would personally just go P-line, dunk, 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 dunk. It doesn't have to be that accurate, as long as it's fairly close, and then you can click on the P-line to form your hatch. If you're not sure if your hatch is going to come up to my standards. You have an opportunity at any stage just to say, what do you think of that scale that I'm using for the hatches? Also ask a friend as well. Bridge, this semester there's no bridge. Last semester there was. This semester there is a sort of a stream / wetlands. I want you to put an arrow on that and a direction of flow. And for those that don't know, water doesn't run uphill, it goes that way. And so that is the direction of where the flow will be, roughly north. Okay? So I'm sure you'll figure that out. The site is over the sort of back of, past the concentrics, over sort of that way. There's no sand, but there is a manhole. Now, the manhole should be, the manhole should be 1050, the outer circle. So, give you a bit of an idea in plan view. It'll come into here by 100 mil. There will be a lid of some sort, which it's a little bit out of perspective. I'll try and draw it a bit better. The man goes down. That is 600, and the diameter of this is 1050. That's a standard manhole. The bottom of the manhole, make the walls about 100 thick, and make the concrete at the bottom about 100 thick. There is normally a gap here that pokes in by 100. There's normally a gap here of 100 as well. That's where all the sludge gathers at the bottom of the manhole. Hello.
Sorry, what was the offset of the lid for the manhole?
Here, I'll leave you to put the lid where you like. Generally, it's close to the outer edge, and if you wanted to see what it looked like, it would look sort of something like this with a wee lip in it. Right, something like that. Actually, sometimes that might go back to over here and go down like that. Yeah. It will look something like that at the top. Anyone know why manholes are circular? Come on, my friend, you can answer this one again. Don't particularly want anyone else to answer it. No? Oh, yes. Okay. That's because when you've got a friend down here in the manhole, you don't want the lid coming down and knocking him on the head. If it's square, a manhole can be put on an angle, it'll go straight down the hole, okay? Circle, it won't. It'll always, no matter how you try to do it, it won't fall down the hole. Logical way. You learn some interesting stuff in this class. So far, how much? Just half a mark so far. You haven't emailed me either, have you?
No, I'll email you later.
Yeah, I might just keep you here to midnight. If it's 1 minute after, it's just like an assignment. It disappears. Okay. So that gives you a bit of an idea of the manhole. No, I haven't done that in the assignment. Yes, I have done it here. Well done for attending class. I've talked about the tree this morning. That becomes an important issue as to where that is, but you're not quite sure about the earthworks just yet, but it may be something you're going to need to write on the plan. The manhole is a proposed manhole, so it should be with the lid filled in, because that's my company standards. Okay? Probably shouldn't talk about Hitlers today, because one of the MPs in trouble for impersonating a Hitler, apparently. But anyway, they were kind of like their own little Hitlers. tell you that. Orchards, there's no orchards, there's no poles, there's no sump, there's no vernacular symbol, but
What's that?
I have no idea where that came from, I'm sorry. There's always somebody asks that every year. Normally they lose half a mark for doing that, but there is trees. So you can use, they're just examples, okay? That's a sideways view. That's something similar to what you drew up last year, though that one is too. Look, I don't care what you put there. There's some really good ones online if you want to grab one. If you want to just draw something fairly basic like last year, as long as the circle is very close to touching what's there, then we won't be going into the drip line. North Points, we talked about that. And there's my famous pink line that I talked about. That's what the survey traverse should look like. Anything hidden should look like that. You'll need another line for, I showed you that drawing with the shed on it. The student should have put that line type on there, but they didn't. They just did another hidden line type. Centre line for the centre line of the pipe, hidden for the outside edge of the pipe. Boundary lines would be thicker if you find one there. If you don't find one there, you don't need to worry about that. Most of the line types will be like that for your continuous drawing. I think buildings and concrete type things should have a thicker, heavier line. Okay, we are now at the section where we talk about the text types. Title is really the title block. Okay, so title block, 7mm text. The title block we're going to be introducing is actually 6.85 or something. We'll leave it at that. You won't get marked down. If you're clever enough to change it, do it. You won't get any extra marks for it. Just leave the title block at that text height, right? The headings are 5. Now, what I mean by headings is, I'll get a student example and I'll show you. Headings are example 2, I think it was. Yeah. Can you see the word notes there? That's 5mm high text. And also the word legend. And also the word locality plan. Okay, and also the word survey coordinates. Now you will need to also maybe use that for the likes of your long section. You may have, may want to write long section underneath it in 5mm. In this year's assignment there's not much else that's 5, so the only other one you've got to worry about is 3.5 and 2.5. Now I'm not actually going to do that calculation. I'll do another one, okay? Because if I did it, it's like me telling you what it is, and then everybody's just going to whisper it to everybody else, and nobody will know how to do the calculation when they find out that this is one of the test questions as well. So the way how you calculate now, these are layout. This is in the layout space, so when you've got your drawing and you print it to PDF, it's in millimeters. Your drawing in model space is meters. So how do you convert, let's take, we'll do the middle one, the 5mm one. How do you convert 5mm in layout to something in meters in model space? And does the paper size come into play, or does the scale come into play? Well, the answer is, it doesn't matter whether it's A1, A2, A3, A4. It has no bearing on it whatsoever. What's really important is the scale. So let's take an example, 5mm in layout, and let's make an example of 1 to 200. Your scale is not 1 to 200, okay? So that will be 5 times 200 equals 1,000 millimeters. Converted it to meters, and it ends up as 1.0 meters. That will be the text height and model space. And yes, this is the only place that you'll see that example. Once it gets rubbed off the board, it won't be in any of my notes or anything like that. You're welcome to come up and take a photograph of that at the end of the class. Obviously you're not 5mm, obviously you're 3 and you're 3.5 and 2.5, and obviously the scale is different as well. For the servos, that's going to be continuous. When you start doing roading jobs, you use the same calculation. So you're learning now something that'll go right through the 14 weeks. For the for the engineers, you're going to be doing millimetre drawings, so it changes again, because you'll be doing structural engineering drawings. Just a little side note, 3.5 and 2.5. 3.5 is the one you're mostly going to be using. That I'm telling you right now, that's the one that's going to be dominant on all of your drawings. Now, when we come to do text type, 3.5mm is the most dominant one you're going to be using. You'll have to do the maths to work out what it is in model space. Please don't do it 3.5 and just think that's the answer, okay? Your arrows will be 3.5. Your text will be 3.5. Your dimension text will be 3.5. Your line offset will be 1/3 of that. Remember those two settings? Line offset, and there's another offset as well. I think there's a text offset. Go back into your notes from last year. So roughly 1/3 of 3.5 is going to be, you'll be aiming at trying to do it at around about 1.2, something like that. Spoiler alert, your cross sections on your assignment are a different scale. So you're going to have to do different size text, different size arrows, different size dimensions for your cross sections. So just be careful of that. So there's the text offset, and there's two lots of line offsets that'll need to be adjusted as well. So I'm teaching you now, if you were in a professional office, how to work out when a client comes in and he goes, oh, listen, I want something that I can read with my glasses on and without them on. Okay, I only got reading glasses, but you know, I'm a bit. So how about you do all the text in 5mm, and I'd like you work out the scale that fits best on the drawing. So you normally will be the one that will dictate the scale. So you work out I'm telling you the scale for the assignment. Normally in an office you would work it out, which is the best size. Then you would take your client request and work out the best size and model space. And he doesn't want to know about dim offsets and all that sort of thing that you guys have learned. You're going to then have to go, okay, what did Roger teach me? Oh, that's right, the most common text is this height, is the same as the arrow and the dimension text. What else did Roger teach me about the dimensions? Everything else is about a third. The other settings that we gave you last semester are about a third. I can't keep on giving you the answers because you get to an office and go, oh, I don't know what to do, I better ring Roger and find out what the best setting is, okay? It doesn't quite work like that. Now, the good thing is that little cat manager, Beaver's away, and often has a lot of these things all preset. So if you open up a company drawing, it's already there for you. But the minute you get asked to do a new one, that's when you've got problems. Okay? What I used to do with my caddies when they first arrived from Unitec way back is I'd give them drawings to get used to it, to alter. Just give them drawings that are already there, just change that text, add that, whatever. And then I'd have to sit them down and say, listen, do you know much about this? And they'd all go, oh no, they didn't teach us that at Unitec. Oh, I wish I taught there, I'd be able to teach you exactly what you need to do, okay? That is important. That's important because you're going to be doing a long section at some stage, but you only need to know the plan dimensions for your plan. That's kind of what the top looks like. What I haven't shown you is what the outlet structure looks like. And because these guys over here are struggling to see that size, I'm going to draw it over here. An outlet structure is pretty much a piece of concrete with, like, if the pipe was coming out of here on me, it would be wing walls at 45 degrees. I would be a concrete slab, and there'd be something here to stop it from washing away all the sand underneath. You've probably seen them. You probably just walked past them and didn't even blink. If you go to Bethel's Beach, you'll see them there. If you go to the North Shore, every single beach has got one sitting there. Some have corroded a bit, some are looking pretty good. The main idea is to stop them from washing away all the water and corroding underneath the pipe, eroding, not corroding, under the pipe. You've been asked to put one in. It's an outlet structure. Is going to be something like this. Let's take that and go 8 times 12 equals 96, so it's 1 to 100. And let's draw an outlet structure over here. Okay, so all the walls are going to be 100 mils thick. Because otherwise you've got no room for the reinforcing bars. It needs to be reinforced because otherwise it'll just basically wash away. The pipe will stick out just a little bit. Okay. And basically what we used to do often was design these things with little cubes here. And what it used to do was the water would splash out of here in a storm event and it would hit these and go way up in the air rather than onto the beach or wherever and start sort of undermining it backwards. There's a lot of other designs which are better than this one I'm just giving you. But at the moment, this is what you're going to be doing. That angle there is 45 degrees. That angle there is 45 degrees. This is roughly 2 meters. You've got a 450 diameter pipe. So from one side to the other side there's 450. That will be, let's make that a meter. Let's make that a meter. And let's make it a meter above. Okay? So that becomes a meter as well. That is a meter. And that is a meter. The only thing you don't know is this height here. You won't know that height until we draw a long section. When we draw a long section, we'll be able to work out kind of where the ground is. I'd like to see it about sort of a meter above the ground, the wing will sort of stick out like that, the pipe will come in here like this. But that point there you'll work out, everybody's will be fractionally different, and that distance there will be at least 100 above that. Okay? So you won't know that height here, the height of this, until we've done the mathematics. Now, as a general rule of thumb, and here's another engineering note, anything that is above 1.5 meters will need to be engineered. There are standard wing walls online from different companies that make them, but once it gets above 1.5, give you an idea, it's about here, on 1.8, so it's about there, right? That's considered dangerous, could fall on someone, it needs to be engineered, which means it'll need an engineer's design with reinforcing. So a note on the drawing would be structural engineer to look into designing outlet structure. So what you're doing is drawing up this as what you're proposing, but a structural engineer will have to come in and design it properly, okay? Which is above you, even the engineers here, it's above your level of station to sign that off. You may be able to design it, you might be capable of that, but you can't sign it off. So you'll find a lot of engineering companies will let you actually have a bit of freedom. They might say, oh, okay, you got the degree at Unitec or whatever. Yeah, I know you've been doing structures 1 and 2, and you know, go for it, design it. But you can't sign it off. There's always someone in the office that will overlook it and sign it off. So the more they trust you, the more they'll let you do it. Same with surveys. You know, registered surveyors are supposed to know everything that's going on, watch everything and check everything. The reality is an office might have 1, maybe 2 of them, and they've got 20 of you guys doing all the damn work out on site. They can't check everything. They start having to rely on their senior technicians to do the double checks and what have you. What a surveyor will be fussy about, a registered surveyor, is tying everything legally into documents. That's where the plans from council come in. You'll get survey plans from council. It has to legally tie in with those, or they can get into trouble. They'll lose their survey licence. Okay. There are some other notes there. You have got survey pegs, which are circular, and like last semester, they will be the same height as the 3.5 text works out to be. There's some notes there on topographical features, and don't ever make the mistake like someone in our office did and ignore anything that looks archaeological. It can be the biggest mistake you'll ever make. In New Zealand, we don't have, like in Europe, you know, things that are 2,000 years old and that, but we do have iwi and sites which are 600 years old, and you know, if you don't pick those things up as a surveyor, you can pretty much just pack your bags up and leave, because if something's in the wrong place and iwi aren't consulted, the whole site can come to a crunching end. Especially in the worst case scenario, burial grounds, but even in a job I was once working on, it was just an area where they used to stop and cook their food, but it's still an ecological site, so you can't just suddenly dig it all up. So the existing site plan, I've given you some really good tips this morning. Don't forget to put all the things on there that are listed here as well. They're only suggestions, but a lot of them are actually there. Have a read through that. Locality plan, it's saying between 80 and 100 mils in layout space. I'm not that fussy on the fact that it has to be that size, but roughly that size is a good size. You don't want it taking over and dominating the drawing, but at the same time, that's roughly what you should be doing. Do not do a Google map, but you're allowed to trace off a Google map. You draw a line off it and then just delete the map. Notes. There's the start of some good notes to start on your drawing. I'm not going to finish them for you, as I'll be doing your drawing for you. Survey coordinates. Most survey coordinates in Auckland are according to Mount Eden grid. For those that aren't surveyors here, there's a trig station up the very top of Mount Eden. Don't personally go up there anymore now because you can't drive up there. That has got, I think it's 700,000 by 300, might be 7 million by 3 million as a coordinate, a GPS coordinate, and most of Auckland comes off that. The reason is you can see that wherever you are, so you can get a sighting on it, a horizontal sighting. This is a local survey. The coordinates are fictitious. However, often what surveyors do when they turn up somewhere and they don't have any start point is they find a manhole, because all manholes in Auckland have got GPS coordinates on them. You can relate it back, go into the council and get the GPS coordinates or whatever. And if they start from the manhole, they can then do a local survey and tie everything back to that manhole. Trouble is, manhole needs to be nominated something, so they might say, okay, let's make that 4,000 by 4,000 or 10,000 by 10,000. The reason why you don't make it 0, 0 is because your first bearing might end up as a negative number. So you try and have a nice big number right from the start. I was involved with the original survey to bring the water up from the Waikato River to Auckland, and we found out a big problem with AutoCAD. Apparently it's only accurate to 9 decimal places. What they tried to do is tie in Mount Eden with way down the line in Waikato, and they were getting discrepancies. And we all thought it was because of the curvature of the earth. It wasn't. It was because AutoCAD is only accurate to 9 decimal places. Only accurate to 9 decimal places, which is 0.00000 of a millimetre. So yeah, I guess at that point they kind of figured that that AutoCAD does have its down points. While we're on that topic, and sorry to disappoint the Flat Earth Society people, but there is curvature in the earth, and so therefore a lot of local surveys are not done off what you guys are used to now, GPS. GPS was a pretty cool thing about 20 years ago, you know, because it related the whole world to New Zealand with coordinates, right? And it was a series of flat coordinates pasted all around the earth. Well, now with local survey grids and all the rest, they actually employ a correction factor every time they do that. So, yeah, GPS is not as accurate as a local survey done from the likes of Mount Eden. You'll find most of the surveys throughout New Zealand are done from a mountain. So you can start employing some of these notes that it's off a local survey. You could say that consult the survey company to find out if it's done in New Zealand Mapping Grid or if it's done in Mount Eden grid. Are the levels sea level, or have they been also done from an estimate? In terms of engineering notes, I've given you a lot of them this afternoon. Most of them are there. One thing we haven't talked about is contractors. Contractors are the bane of all good site engineers. They are always pushing them to the limits. You will probably need to put some restrictions on the contractors because it's beside a polytech. Noise, sound, dust, and doing it in the school holidays. So they're all notes that can be ably employed on your drawing. Okay, there's a checklist. You'll see after we've done the drawing today what happens in terms of the check. I'm going to now, I want you all to download the survey drawing. I'm now going to open it. You also need to set up your ARG like you did last semester. If you've forgotten, there's a PDF file there as well on Moodle. And I'm going to open up the survey drawing. So you should get something like that when you open it up. I'll wait for you guys to start catching me up. So by the way, the survey contours are at 2.5. That's the only little the little height ones you're going to be doing. You need to do the maths. I probably need to write that on the board as well. So the 5 is the headings. You need to do the maths at the scale to work it out. 3.5 is most of the text, and 2.5 is the contours. We always do contours in smaller text because it's not as important on the drawing as the actual design or the features we're trying to show. So I've been kind to you and I've also been not so kind to you. If you have a look at the layers, you'll see there are a bit of a mismatch of layers. There's not many there, probably nowhere near enough. I would suggest you're probably going to need 3 times that amount this time you start labelling everything up. And some you may have to delete. I've given you a north point. You may use that. I would suggest it's very large, so please, if you are going to use it, make it smaller. There's text on here already, but when you do your calculations, you're going to find that text height of 360, 0.360 is wrong, and a text height here of, can I even see what that is? I'll list it. 43 is also wrong. So the text heights are completely wrong that are on the drawing. Please don't use those text heights. I'll give you an example of over here of how to change text heights cleverly. So we have some, I'm copying this over to the side. Let's say this text height here is 0.360. Okay, so we take out our calculator and we work out that that text height is 0.15, right? What you do is you double click and you highlight that and you make that 0.15. See how small it is? Can you see that on the board? Maybe I'll turn the light out. Let's say it's supposed to be 0.15. It isn't. That is incorrect. Do not copy this. Do not copy this. But I'm showing you a technique in AutoCAD. So we've made it 0.15, okay? Now, I want to make all that text there 0.15. So I go up here to this thing here called Match Properties. I click on it. I call it the paintbrush because when you dip the paintbrush in what you want, which is that one, I can now basically go around them all, and within seconds, everything it touches will go to that same text height. Now there are disadvantages, and I'll show you the disadvantage. Watch this. That just flipped, that flipped, and that flipped. We didn't want that text flipping. Because what it does is it takes on the same properties as the thing you're paintbrushing. So unfortunately, it'll take on the right height, but if that's on the wrong layer, let's say that layer is a layer called fence, not text, you've got to check that before you do it, because you'll be making everything fence. Alright? But it's a really good command. Once you've done one, you can whip around and do the other ones. This is a pretty dominant thing on the drawing as well. You're welcome to take the centre point of that and change it to a very small circle, open circle or something. No, not an open circle, that's your traverse, maybe a wee cross or something. Okay? The pegs won't be a cross like that, the pegs will end up a circle. Now those pegs may be in the right place, in which case, yee-haw, I've just plotted two of them for you, and they might not be in the right place. So when you do your pegs, make sure you do them properly, don't assume anything. Never do that with anything, any drawing like this. Now, you're not really that interested in that because you all knew how to change the text type anyway. You're more interested in what I'm about to show you now in terms of the title block. So, I'm just going to undo a little bit here back to where we were. So the drawing's presented itself like that, okay? The first thing I always do with drawings is I turn on any layers or freeze any layers I thaw or turn on any layers that aren't turned on. Because you never know what might be sitting out further out that the surveyors or the company that's surveying decided they wanted to freeze and it really shouldn't have been frozen. Okay, the next thing I do is I'll go into my layout space. Now look at this. You guys have been given a layout tab that is already named. Isn't that brilliant? The only problem is it's got the wrong name on it. So you're going to have to come up with a name for the tab. In other words, what is this assignment called? What is this drawing called? So you need to right click on and change that. Anyway, I'm going to click on that. Well, it's starting to look quite promising. I've no idea what the text height here is. What the title block is, what paper size it is. One clue that's a wee bit of a worry is that when you did full bleeds for me last semester and Ingrid, that dotted text was always way out here, wasn't it? By the edge. So, got a feeling it's not full bleed. Not sure on the paper size, so let's get in there and do something about this. So I'm going to go File, no different than last semester. File, plot. So this is all repeat, continue. I'm going to find my drawing to PDF and I'm changing that to your full bleed. So there's nothing different there except that you have to do A1 full bleed. And A1 is 841 by 594. 841 by 594, the big one first, not the little one first. Now, can anyone see something there that's not quite right? I know it's late at night, but what am I doing at the moment? Should be 1, correct. So do that at 1, apply the layout and cancel, and look what's happened. Where's it gone? The same place that it would have gone if you didn't turn up to today's class. It's very tiny. I'm just making it over here. Inside the viewport, Z enter, E enter. This should be bringing back some lovely memories. And there it is. Okay, I'm going to click outside the viewport. I'm going to move this up a bit for my title block. Okay, just before I put my title block in, I need to get the scale right. The scale is 1 to 100. So I go inside the viewport, I go Z enter, 1000, oh, yes there is, /100 XP. Is that correct from last semester? Let's see what happens. Believe it or not, that's correct. So this is what often happens when you're doing drawings. The client asks for 1 to 100. You want to show him the whole of Unitec. He wants 1 to 100. So you're going to have to come to some sort of compromise. He's not moving on that